Right, this is an energy level diagram of an atom. Originally in class we drew our nucleus as the thing in the middle, and we said here's the shells here, and the electron can jump from one shell to another. But another way of drawing that is to open them up, instead of drawing it as a circle, just to draw them as lines. So these shells are equivalent to these are the shells here. The first question is asking us, an atom is in the third excited state, so it's in this state here. It can emit photons with 6 different values of energy. Use arrows in the diagram above to show the transitions that produce these 6 possible photon energies. What I'm going to do is I'm going to draw in green first my working, and then I'll draw over here my actual one. So when you've got to do your answer, you'll only do the actual one. So the electron can start here, and it can jump, if it wants to, it can jump all the way down. And that's one of the photons will have that energy, 3.01 electron volts. What's another way it can jump anywhere to emit photons at different wavelengths? Well, it could jump to here. It could then jump to here, and then it could then jump down. So now I've got 1, 2, 3, 4. It could also jump to here, and then jump all the way down. And the other, so that's 1, there's 2, there's 3, there's 4, there's 5. That one's the same as that one, so it's 4 as well. It could also jump from here to here, and then all the way down. It's the same as number 2 over there, but this is a new one, this is number 6. So let's just draw those individual ones again, just to show 6 different arrows. I don't want to confuse the examiner by putting more than 6 on. So I can jump there, there's a jump, there's a jump. It can also go there, and it can also go here. Here's my 6 arrows. I did an experiment with a large number of the atoms. Virtually all the atoms are in one particular excited state, and photons with a range of energies are directed at the atoms in order to produce an absorption spectrum. So it absorbs, which means electrons absorbing energy, and they jump up. It is found that the atoms strongly absorb photons of this and this. Determine the initial excited state of the atom, show your reasoning clearly, and relate your explanation to the energy level diagram in figure 5. Alright, so 0.51 electron volts is the energy needed to jump. 0.51 is the energy needed to jump from here to here, because 2.36 minus 1.85 equals 0.51. So that's from first to second. The jump from first to second excited state. The other one, 1.16, is energy needed to jump from here up to here, because 3.01 minus 1.85 equals 1.16. So that was from the first to third excited state. Therefore, initial state is the first. Both of these are starting from the first. To the last question in the exam. De Broglie suggested that the quantized energy states of an atom could be explained in terms of electrons forming standing waves. Describe how the concept of a standing wave can help explain the quantized energy states of an atom. You may include a diagram. Cool, that's worth 2 marks. Alright, let's start my working down here, and I can put my diagram up here when I come to it. So, electrons only form stable orbits if they can form standing waves. Electrons have wave properties. And the standing waves are only formed if the circumference of the shell is a whole number of wavelengths, e.g. C diagram. There'll be a full stop. So here's my electron shell. Let's see if I can draw the whole number of wavelengths in here. Here's a small one. Let's see if I can not draw a whole number of wavelengths in here. Okay, whole number of wavelengths. Whole number of wavelengths. Standing wave doesn't form standing wave. And this is not whole number of wavelengths. Done.